this for now. Today we're going to be reviewing the quotient rule. This is one of the rules that is part of the law of exponents, which you began studying by looking at Mr. Samuel's introduction video and his video on the product rule. So as we begin, I want to point out a few things. First of all, you'll notice on the left, we start off with dividing monomials. So I'm not sure if Mr. Samuels went over this with you, but one thing I want to point out is this root here, mono. Mono literally means one. So when you see something that says monomial, it means one term. So that's what monomial means. So to divide monomials, we use something called the quotient rule. And you need to remember what quotient means. So quotient means division. It's the answer to a division problem, right? So that is what quotient means. And that's what we're referring to. You'll notice here that you see a fraction bar. Well, the fraction bar also is a way to represent division. So whenever you see the fraction bar, you should think to yourself, this is a division problem. Okay, so now we're going to be discussing what the quotient rule actually says. What it says is that if we have one monomial, x to the a power, and we divide it by x to the b power, we can write that as x to the a minus b power. So what we'll be doing is we'll be subtracting the exponent b from a. So let's look at some examples here. We're going to do some odd problems. You'll notice that we have here the same base, 12, and they're raised to the 7th power and to the 5th power, and it's expressed as a fraction. You need to remember that that fraction bar represents division. So we'll simply begin by taking 12. We'll rewrite it. And then we're going to take our exponent in the numerator, 7, and subtract the exponent in the denominator, 5, from 7. So we know that 7 minus 5 is 2. So to express this answer, we would write 12, and then we would write to the 2nd power. Now, if the directions further set up here to simplify, you could go ahead and simplify that, and you should know that 12 squared is 144. Okay? Sorry that the parentheses is a little odd. Now let's look at problem 3. So again, same base. Now you'll notice here, you don't see that there is an exponent. But just because you don't see one doesn't mean that there isn't one there. For example, what could be there? What exponent represents 4? Well, it would be 1, right? So 4, we write it again, and then it would be 10 minus 1. So 10 minus 1 is 9. So simplifying this, it would be 4 to the 9th power, which you could then use your calculator to simplify and find out that that equals 262,144. Let's look at problem 5 now. Again, we're going to write our base, which is 8, and subtract the two exponents, 6 minus 6. Well, 6 minus 6 is 0. That gives us an answer of 8 raised to the 0 power. But you'll need to remember that any base raised to the 0 power is equal to 1. So number 5 is actually 1. All right, now let's take a look at number 7. So here we have variables. So the question is, can we use the quotient rule when we just have variables? And the answer is, of course we can. Again, we would know that we have x as our base, and we would subtract our exponents. So we would subtract 10 minus 2. And we would then rewrite it. So 10 minus 2 is 8. So the answer to this problem, number 7, is x to the 8th power. And we can't simplify that anymore because we don't know what x equals. Look at number 9 now. So here we have p, but again, we don't see an exponent there. Just because you don't see it doesn't mean it's there. Assume that the exponent is 1. So we would write p to the 1 minus 4, which would be equal to p to the negative 3, because that's what 1 minus 4 equals. But you'll notice here up in the directions it says, express your final answers using only positive exponents. So now you'll have to remember that whenever we see a negative exponent, we will write the reciprocal of the base. So our reciprocal would be 1 over p, and then it would be raised to the 3rd power. So that's our answer. Okay, so moving on, let's look at number 11. So it looks confusing because there's multiple variables here, but you're going to use the quotient rule again to simplify your answer. So we would have r, and then we would subtract negative 3 from 2. So it would be 2 minus negative 3, which gives us positive 5. And then we look at s, because that's the same base. Negative 5 minus 2 gives us negative 7. Again, the directions said to rewrite this using only positive exponents. So our numerator becomes r to the 5th, and our denominator is s over 7, because we have to write the reciprocal of s and then raise it to 7th power. So this is your answer to number 11. Okay, now let's take a look at this little note here. Examples with coefficients. First, I want to point out this word coefficient. Coefficient, co means together. And a coefficient is literally a number or a constant next to a variable. So I'm going to write this down for you. Wait, not there, maybe here. A coefficient is a number or constant placed before a variable in an algebraic expression. And the operation that you would use is multiplication. Okay, so that's just in case you don't know what a coefficient is. So when you have examples with coefficients, the first thing that you're going to do is you're going to divide the coefficients, and then you go and you simplify the variables using the quotient rule. So let's take a look at number 13 now. 24 divided by 8, because we're dividing the coefficients first. 24 divided by 8 equals 3. Now we simplify the variables using that quotient rule. So I'm going to write my variable c, and then 10 minus 3 is 7. So my exponent is 7. Let's take a look at 15. The coefficients are 10 and 2, so we'll divide them first. 10 divided by 2 is 5. And then we have to look at our x and know that we have 3 minus 4, which is negative 1. Well, we're not going to write it with a negative exponent, so we're going to rewrite this using positive exponents. So again, 5 becomes my numerator, and then in my denominator is x, or you could write x to the first power, but you don't need to. Okay, so there we have it, and there's a few more examples here on the back, and I think I have time to do 1 or 2 more with you. So here we have 3, 6. So we know that 3, 6 is actually equal to 1/2. And then we have our h, and 4 minus negative 1 would be to the 5th power. Now you can leave it like that, or you can rewrite it with h to the 5th in the numerator over 2. So now what I would like you to do is go ahead and finish the odd problems here, 19 and 21. And then I want you to do all of the even practice problems that we haven't done so far, and all of the mixed practice. I would like that done by tomorrow. Have a great afternoon. If you have any questions about this video, please feel free to post a comment in the Google Classroom. Have a great day.